So when you want to fetch data from the server, normally you use the Ajax, which is asynchronous JavaScript, or the fetch API, which is a newer version, wherein you send a request and then you get a response back. Now, what if we need to update data frequently? Like suppose there's a new offer that you want to show instantly. So every, say, 10 seconds, you could keep on checking the server whether there's a new offer. So every 10 seconds, you'll send a request. Is there a new offer? No. Is there a new offer? No. This is what's called short polling. So the next evolution of that is something called long polling, where the difference is you still send a request every X number of seconds, but the server will not reply back immediately. So in short polling, you send a request, no data, and then the server immediately sends a request, reply, no data. In long polling, the server will get a request saying that ask from the client asking if there's any update. The server will hold that request for a short amount of time. It's configurable. Generally, they keep it around 30 seconds ish. And then if there's no data in that time, it'll reply with no data. Otherwise, it'll reply with the updated data. One thing that we could do to overcome polling is having a persistent connection. So what is a persistent connection? It's a connection that's always maintained between you, the client, and the server. There's something called SSE, so server-side events, which is also called server push, which maintains a persistent connection between you and the client, but it's unidirectional. So it's one-way communication only from the server to the client. Now, what are the drawbacks of the three methods that we just now discussed? They're not real-time enough. In SSE, which is server-side events, the disadvantages, the data is relatively real-time, but the three main disadvantages: you you cannot detect when a client is disconnected, and also the browsers like Chrome have a limit of 6 connections that are allowed in the browser. So suppose a person has 7 tabs, and then all 7 tabs use SSE for their updating of for getting real-time data. Then one tab will not be able to work, and then it doesn't have binary support. So this is text data, and then binary data is like images, etc. Now let's look at WebSockets. WebSockets is a thin, lightweight layer about TCP. TCP is Transmission Control Protocol, which is internet protocol, which is a reliable internet protocol for transmitting data. It provides a bidirectional communication, and it can supports both text and binary data. So this is how a WebSocket is created. So first you have a normal request response connection, and then the server will send a upgrade request. Once the upgrade request is negotiated, so the server will send a request to the client. The client will saying that I want to upgrade this HTTP request to a WebSocket connection. Once they both agree, you will get a persistent connection. Now, what are the advantages of WebSockets? So it's bidirectional. It's really real time. You can send and receive data immediately. Anytime there's an update, the server can immediately send the data to the client, and anytime the client can similarly send the data to the server. There's less overhead. So an HTTP request is about 2000 bytes of overhead, where a WebSocket is only 2 bytes. So there's a 1000x difference between them, and it has binary data support. What are the disadvantages? There's no caching support. The disadvantage of caching is you might be seeing old data, but the advantage of caching is you don't have to hit the server every time. And then WebSocket is a little more complex than HTTP. And then it's affected by fluctuating networks. And if you change your network, like suppose you are on a mobile and you change your connection from a 4G to a Wi-Fi, then the WebSocket gets cut, and you have to recreate it. And it's heavier on the server. So since it's a persistent connection, your server can handle fewer socket requests than HTTP requests, and then load balancing is more complex. Now let's look at the WebSocket API. It's quite a simple API. So you create a new WebSocket connection by passing. This is in the browser. It already has inbuilt support for WebSocket. So you call new WebSocket, and then you pass in the URI of the WebSocket server, and then you get a bunch of callbacks. Connection is open, you code this part will be executed. When the connection is closed, this part will be executed. Any error is there, this part will be executed. And anytime a message is received by you from the server, this part is there. And then if you want to send data, you just call the send method, and then you send data to the server. Similarly, the server side is also quite simple. So I'm using a library called WS. For different languages, there are different libraries. You create a reference to the object, and then you mention the URL, and then similarly you get all the callbacks. So when message is received, when the client is closed, when the client is open, etc.